Lesson 32, Simplifying and Evaluating Expressions with Integer and Zero Exponents. An algebraic expression may contain exponents that are positive, negative, or zero. So, here we're talking about powers of 2. So we have 2 to the 4th power is equal to 16. Let me get my pen out here. Okay, 2 to the 4th power, we know means 2 times 2 times 2 times 2, 2 4 times, and that gets us 16. 2 to the 3rd power gets us 8, so we have 2 times 2 times 2, gets us 8. 2 times 2, we know is 2, or 2 to the 2nd, excuse me, is 4, and 2 to the 1st is 2, but it says what are the next 3 powers? Well, what's happening from 16 to 8? We're dividing by 2. No, it looks like it's supposed to. From 8 to 4, we're dividing by 2. From 4 to 2, we're dividing by 2. So the pattern, you would think, would continue, or at least I hope you do. So if we had 2 to the power of 0, because we're going down 1 in powers each time, we hopefully already know that anything raised to the power of 0 is always equal to 1. Here, we're taking 2 divided by 2, and that is, whoops, going to get us that 1. Okay, so next, that's our first power. So the next power, if we're going down 1 for our powers each time, is going to be 2 to the negative 1. Well, what's that going to equal? If I'm dividing by 2 each time here, 1 divided by 2 would give me 1/2, right? One more time, we have 2 to the negative 2nd power, because we're going down by 1 each time, equals, and if we took half of 2, we're dividing by 2, half of 1/2, I didn't mean to say 2, half of a half, that's going to give me 1/4. This, remember, is the same as dividing by 2, because 2 is over 1, so I could flip it and multiply. That's where I got that from. So these would be the next 3 powers. 2 to the 0 and anything to the 0 is equal to 1. 2 to the negative 1st is equal to 1 over 2. And 2 to the negative 2nd is equal to 1 over 4. So this is the rule for negative exponents, and that is x to the negative n equals 1 over x to the n, and x to the n equals 1 over x to the negative n. What they're saying here is that you can take this negative exponent and make it positive by taking the negative exponent with its base to the opposite side of the fraction bar. Okay, so here when we moved it down, that's what happened here. It became a positive, which left us with that 1 on top. Over here, it was already a positive, so when we moved it down, we took it and we moved it across that fraction bar, it changed the sign. So instead of being a positive, it became a negative. The zero exponent rule is that x to the 0 is equal to 1. We already said that anything raised to the power of 0 is equal to 1. So it says simplify each expression. It's wanting us to write these with a positive exponent. So I know that this is understood over 1. And this negative 9 I make positive by taking the negative 9 I can make positive by taking that negative exponent with its base and moving it across the fraction bar. When I do that, I'm left with 1 on top and x to the, instead of a negative 9, it will now be a positive 9. Final answer. On problem B, I have d to the negative 2 over c to the 3rd. The only thing that I need to simplify here is the negative exponent. I need to make it a positive. So to make this negative 2 positive, I'm going to take the negative exponent and its base, and I'm going to move it to the opposite side of the fraction bar. When I do that, again, I'm left with 1 on top over c to the third stays because it was already there, and that d to the negative second becomes d to the positive second. Final answer. I would like for you to pause the video and try to do this one on your own. On c, my negative exponent is in the denominator. So I'm going to take the negative exponent with its base, and I'm going to move it up across that fraction bar. When I do that, on top, I technically have 1 times a, and instead of negative 5, I will then have a positive 5 over 1. Well, I don't have to show this 1 times, and I don't have to show the 1 on the bottom either. So my final answer here would just be a to the 5th power. Final answer. It says evaluate each expression for a equals negative 7 and b equals negative 4. So I hope that you remember that whenever I'm substituting for a variable, I always use parentheses. So instead of a, I'm going to substitute negative 7. That's being raised to the 0 power. And b is negative 4. And that's being raised to the 2nd power. Okay? So to simplify this, I need to actually find what those exponents make my bases equal to. So I hope that you remember that negative 7 to the 0, or anything to the 0 power, is going to be just 1. So this is 1 times negative 4 squared means negative 4 times itself 2 times. I just wrote a 2 instead of a 4. Sorry about that. Negative 4 times itself 2 times because of that exponent of 2. So now what I have is 1 times negative 4 is negative 4. Negative 4 times negative 4 is a positive 16. Final answer. On the next one, we're doing the exact same thing. So I have 8, and instead of b, I'm going to plug in negative 4, which is being raised to the negative, to the negative 2nd power, times b, which again is negative 4, and it's being raised to the 1st power. This is multiplication, it looks like a minus. There we go. Okay, so the first thing that I need to do is follow my order of operations. An order of operation tells me that I have to do parentheses first, and I can't simplify anything inside of these 2 sets of parentheses. So next on my list of order of operations is exponents. So I need to simplify these exponents. When I have a negative exponent, I can't simplify it until it becomes a positive. So I'm going to have to put this whole thing over 1. And this negative 2 I can make positive by taking it and its base. The negative 2 only applies to this negative 4 here. And I'm going to move it across that fraction bar. And then I should already know that negative 4 to the 1st power is just going to give me negative 4. So on top I'm left with 8 times negative 4 over this moved down, remember, so it's 1. I don't need to show that anymore because it's 1 times this, which is going to be negative 4. And instead of the negative 2, it is now going to be the positive 2. So on top, 8 times negative 4 is negative 32. On the bottom, I have negative 4 times negative 4, which is going to give me a positive 16. Negative 32 divided by 16 gives me a negative 2. Final answer. So the quotient rule for exponents says that if m and n are real numbers and x isn't 0, then x to the m over x to the n equals xm minus n, which is equal to 1 over n minus m. So what they're saying is, normally we know that whenever we're dividing with the same base, we subtract the exponents. But I can also subtract by bringing this one down. And whenever I do that, I'm going to be subtracting whatever it is. That's where they got this, because up here will now be a 1. So they want us to simplify each expression. And what I need to remember is that when I simplify, I always want to have positive exponents. Unless the directions for some reason tell me to have negatives, I always want to have positive exponents. So here I have x to the 9 and x to the 6. Those are both positive, but it's not simplified because I have a base of x on the top and on the bottom. So to change that, I'm going to have to do my quotient rule for exponents. And since they're both positive, I'm just going to do this like normal, especially because this 9 has a greater absolute value. So I want to subtract 6 from 9. That will keep it positive. So this is going to come up, which is going to give me x to the 9th minus the 6th, which gives me x to the 3rd. Final answer. On this one, the same thing is happening, but on this one I have a negative, and I want to change that negative to a positive. So to do that, I'm taking this one and I'm bringing it up here. Now, I'm going to show you this in two different ways. First is the quotient rule, which says that if I have x to the 9th, then I'm going to subtract whatever this is. So this is a negative 6. And minus a negative gives me a positive, so that would give me x to the 15th. I could also do it the way that we were doing it earlier by just making that 6 a positive first. So when I move it up, I would have x to the 9th times that x to the 6th, because it would be positive instead of negative. And we should remember that when we're multiplying by the same base, we add the exponents, which would get us right back to that original answer. On this one, I'm going to move anything that I need to make sure that my exponents are positive in the end. So here, this x is raised to what power? If we don't show a power, we know that it is automatically understood to be a 1. So I have x to a positive 1 and x to a negative 4. That means that I want to move the negative up. And I have x to the negative 6th and x to the negative 5th. Whenever I have negatives like this, I want to move the one that has the largest absolute value so that I end up with a positive. So between negative 6 and negative 5, the larger absolute value is that negative 6, so I'm going to move it down. And then I have z to the negative 3rd over z to the 1st. I hope you remembered that. This one's a positive, this one's a negative. I want to move the negative, so I'm moving it down. So what's on top? This x to the 1st, I didn't move it. It was still there. And when I move this, I'm going to follow my quotient rule, which means I'm going to subtract that negative 4, which is the same as just adding 4. So on top, I have x to the 1 plus 4 is 5. On the bottom, I have y to the negative 5th minus the one that I'm moving, which is negative 6. Negative 5 minus a negative gives me a positive. So on the bottom for y to the negative 5th plus the 6 gives me y to the 1st, or just y. And then I have z to the 1st, which was already down here, minus what I'm moving, which is that negative 3, which is giving me a double negative, so a positive. So I have z to the 1st plus the 3rd gives me z to the 4th. Final answer. A kilometer is 10 to the 3rd meters, and a millimeter is 10 to the negative 3rd meters. How many times larger is a kilometer than a millimeter? Express the answer in exponential and standard form. I would like for you to try to do this one on your own paper, and make sure you have your notes for class tomorrow. Have a good night.